Evening.
Yeah, good evening.
Sorry, the topics we're covering today is Pearson and Spearman correlation, simple linear regression, and sampling techniques, then finite and infinite populations. So we're going to start with correlation. So correlation measures the strength and direction of relationship between two quantitative variables. For instance, like you are reading, and when you are reading, you are reading so that you get more knowledge. So the more you read, the more you get more knowledge. So it's measuring the strength and the direction which the relationship of these two quantitative variables are. So positive correlation, as one variable increases, the other also increases. So an example is the more you are reading, the more knowledge you are getting. So as you read more, you get more knowledge. Then negative correlation is as one variable increases, the other decreases. For instance, you are not reading, um you are not reading, as is increasing, that you're okay, you keep watching movies for a longer time, your knowledge is not going up, it's going down. So as the more you watch movies, the more that your knowledge decreases. Then no correlation is like when there's no pattern between the two variables, like there is no relationship between the both of the variables. So that's for correlation. So when it's positive, one variable is increasing and the other is increasing. That's a mutual, it's mutual. Then negative correlation, as one variable increases, the other decreases. No correlation, no apparent pattern. There's no pattern between there's no relationship between the variables. So the next thing is Pearson's correlation coefficient, which is R. It measures the linear correlation between two continuous variables. The formula is R n times sigma xy minus sigma x times sigma y over square root of n sigma x square minus sigma x square. That's okay, I'll explain it, times n sigma y square minus minus sigma y square. So n is the number of data pairs. Sigma xy is the sum of the products of x and y. That's, you find the products of x, find products of y. Then you multiply x and y, then you add everything together. That's sigma xy. Sigma x is the sum of the x values. Sigma y is the sum of the y values. Sigma x square is, first of all, you square all the x, then add everything. That's sigma x square. Then sigma y square is the sum of y squares of y. So when you find r using this formula, so for you to interpret your answer, if r is close to 1, or if r is 1, is a strong positive correlation. If r is minus 1, it's a strong negative correlation. If r is 0, it's a no correlation. So let me say r is 0.5. That's a moderate positive correlation because it's close to 1. So you would start measuring from 0 to 1. That's 0.1, 0.2, it's their positive correlation. But then when it's 1, it's a strong positive correlation. When it's minus 1, it's a strong negative correlation. That's how to interpret your answer after using this formula. So we'll solve an example now. So given x is 2, 4, 6 and y is 1, 3, 5 and 7. So the first thing you find is sigma x. That is, you add 2 plus 4 plus 6 plus 8, and that's 20. Then the next thing you would find is sigma y. That is, you add all the values of y. That's 1 plus 3 plus 5 plus 7. That will give you 16. So you would multiply x and y. sometimes it's better to do this in a table so you don't get confused. So for instance, we're using a table. You have your first table here as x. Sorry. So sometimes it's better to use a table. You can have the first table here as x, then y, then you have xy, then you have x square, then you have y square. So you write out 2, then in the x column you write 2, 4, 6, 8. Then next in the y column you write 1, 3, 5, 7. Then in the xy column you do 2 times 1, that's 2, 4 times 3, 12, 6 times 5, 30, 8 times 7, 56. So you write them out in the xy column. Then for the x square column you would find the squares of the x values. That's 2 square, 4 square, 16, 6 square, 30, sorry, 6 square, that's 36. Then 8 square, that's 64. You write it in the x square column. The same thing for the y values. 1 square, 1, 3 square, 9, 5 square, 25. Then the 7 square is 49. Then you add up all your answers. For example, the xy column, after multiplying 2 and 1, 4 and 3, 6 and 5, 8 and 7, you add up everything. That is going to give you the summation of x and y. That's sigma xy, which is 100. So for the same thing for the x square column, you add up all your answers, and that will be giving you sigma x square, which is 120. Same thing for the y column, you would add up all your answers, and that's sigma y square. That's summation of y square. That was going to give you 84. So the number of pairs is 4. When I mean pairs, I mean 2 and 1, that's a pair. 4 and 3, that's a pair. 6 and 5, that's a pair. 8 and 7, that's a pair. So they're in 4 pairs. So using the formula, from the formula we have n times sigma xy minus sigma x times sigma y over square root of n times sigma x square minus sigma x square. Don't get confused. This first one is sigma x square. That's summation of sigma x square. That's when you add up all this x square, the summation of it. That's the first one. Then the second one is sigma x. So is the summation of sigma x. That's the summation of x. Then your answer after summing all the x, then you square it, not x square. That the first one is when you find x square, you now add up that column, you now have sigma x square. Then this second sigma x, this one is sigma x. That's adding all the x values. Then your answer after adding it, you find the square of that. So plugging it into your formula, n is 4. So 4 times 100 minus 20 times 16 times all over square root of 4 times 120 minus 400. Because I told you we're going to find 20 square, that's sigma x square. So 20 square is 400 times 4 times 84 minus 256. The same thing is for this y side. This is summation of y square, and this is summation of y, then you square it. So when you substitute into the formula, remember you solve your brackets first. After solving your brackets, then you would find the square root of the denominator, then you divide through. When you finish solving, your answer is 1. So for you to interpret this answer now, it's a perfect positive correlation. If your answer was a -1, that's a perfect negative correlation. If your answer was 0, you would say there was no correlation or no correlation. So that's it for Pearson's correlation R. Do we understand, or should we move to the next subheading? Do we understand, or should we move to the next subheading? So Spearman's rank correlation. So it's used for when data are ordinal and not normally distributed, like when you're ranking something first, second, third, this is greater than this is lesser than this. So this is when you use Spearman rank correlation. The formula is R subscript S. This is meant to be written as RS. So this is R subscript X is equal to 1 minus bracket 6 sigma d square over n bracket n square minus 1. So D is the difference in ranks, N is the number of pairs. So this is an example. They said giving a student rank in maths is equal to 1 and rank in English is equal to 2. That's the first pair. Student B, rank in maths is equal to 2 and rank in English is equal to 1. That's the second pair. Student C, rank in maths is equal to 3 and rank in English is equal to 3. Find the deviation for each, that's this square. So for A, the deviation is 1 minus 2, that's the first one minus the second one. So minus the second one square. So it's 1 minus 2 square, that's 1. And 2 minus 1 square, that's still 1. Then 3 minus 3, that's 0 square, that's 0. So you add up the deviation square, that's sigma d square, 1 plus 1 plus 0, which is 2. And n is the number of pairs, and there are 3 pairs in this question. So your answer, finding the answer by putting your values in the equation, in the formula. That is 1 minus 6 times sigma d square, and sigma d square is 2 over n bracket n minus n square minus 1. So that's 1 minus 6 times 2 over 3. Then n square is 9. So 3 3 times 9 minus 1. So that's 1 minus 12 over 24, and your answer is 0.5. So for you to interpret this, now this is a moderate positive correlation, because I remember I said if it's close to 1, that's positive. If it's almost close to -1, that's negative correlation. So this is a detailed way of interpreting the values, your answer. So if your answer is 1, that is a perfect correlation. If your answer is between 0.7 to 0.9, that's a strong positive correlation or relationship. Correlation is same thing as relationship. So if your answer is between 0.4 to 0.6, that's a moderate positive correlation. If your answer is at 0.1 to 0.3, that's a weak positive relationship. If your answer is at 0, that's no correlation. If your answer is at -0.1 to -0.3, that's a weak negative relationship. If your answer is at 0.4 to 0.6, that's a moderate negative relationship. If your answer is at 0.7 to 0.9, that's a strong negative correlationship or correlation. If your answer is at -1, that's a perfect negative relationship. So this is how to interpret your answers for both Spearman rank correlation and Pearson's correlation. I hope we understand this part before we move to the next thing. Is there any confusion anywhere? Okay, so introduction to sim. Is there any confusion anywhere? So introduction to simple linear regression. So let's quickly define what this is. It's a method to model the relationship between a dependent variable and an independent variable using a straight line. So like you're trying to find out the relationship between this variable and another variable, like two different things that are relating using a straight line. It models the relationship between the dependent and independent variable. For example, you're predicting weight from height. So you're trying to like look at somebody and predict, oh, this is the person's weight by looking at the person's height. Or you're trying to predict a person's height looking at the person's age. So this is like you using a straight, like you're trying to like, so you're trying to like do this thing, um find a relationship using a straight line. So the formula for getting the line is y is equal to a plus bx. That's the formula you use in getting the equation of the line. So y is the dependent variable, x is the independent variable, a is the intercept, and b is the slope. So let's look at an example to explain this very well. Or first of all, like let's find out the formulas for you to get b and for you to get a. So when you a for you to get b is n sigma xy minus sigma x times sigma y over n times sigma x square minus sigma x square. And for you to get a is a sigma y minus b sigma x over n. So you have to be careful with finding these answers, because what you get in b is what you're going to use in finding a. So you want to make a mistake in your b, you've already made a mistake from there. When you get a, your answers can never be correct. So this is an example. You are giving x and y. So you first of all, the same thing, you find sigma x, which is 1 plus 2 plus 3 plus 4, which will give you 10. So you find sigma y, which is 17. The same thing, using a table, you find xy. X xy is 50. You find xy, which is 1 times this, 1 times 2 plus 2 times 3 plus 3 times 5 plus 4 times 7. And that's the summation of it is going to give you 51. So sigma x square is the same thing as finding 1 square plus 2 square plus 3 square plus 4 square, and adding it together is going to give you 30. And n is the number of pairs. So finding the number of pairs is 1 and 2 is a pair, 2 and 3 is a pair, 4 and 7 is a pair, 3 and 5 is a pair. So we have 4 pairs now. So the first thing for you to do is to find b. So you put these answers we've gotten now in your equation of b, which is in your formula of b, which is n times sigma xy minus sigma x times sigma y over n times sigma x square minus sigma x all square. So you have 4 times 51 minus 10 times 17 over 4 times 30 minus sigma x all square. So when you put this in your question, you first of all solve the inside bracket first. Multiply out. 4 times 51 is 204. 10 times 17 is 170. 4 times 30 is 120 minus 100. Then you solve the two individual brackets. That's 34 over 20. So your answer is 1.7. So you've gotten b, you would solve for a. And a is sigma y minus b times sigma x all over n. And we have Sorry. And we have sigma y as 17 minus 1.7, which is b, times sigma x over n. So we have 17 minus 17 over 4. So your answer is 0. So you put it in your equation of y, and that was y is equal to a plus is b times x. So you have a is 0, that's 0 plus 1.7x. So we have 0 is going to cancel itself out. So we have y is equal to 1.7x. So this is the equation, this is the line that we're using to find the relationship between the y and x. So for instance, you can ask, oh, what would be a person's grade if he studies for 5 hours? So now y is the dependent variable, because we're asking what would be a person's grade if the person studies for instance, 2 hours. So as y is the dependent variable, y is depending on how many hours the person will study. So your answer is going to be, that's your x, which is the independent variable, is 2. And we're asking what is going to be your test score if you study for 2 hours. That means your test score is y. So for you to find y, it's going to be y is equal to 1.7 times 2, which is going to give us 3.4. So your test score is going to be 3.4. So if x was 10, let me say, for instance, what would be your score if you study for 10 hours? So your answer is going to be 1.7 times 10. So for instance, x is 10. As you studied for 10 hours, what would be your score? Y is going to be 1.7 times 10, which is going to give you 170. So y is 170. So that is it for simple linear regression. So we're using a line to find a line or an equation to find out the relationship between two variables. So this is the way of interpreting regression results. So the slope b indicates how much y changes for a unit charge of x. So if x is 1, how much will y change? If x increases to 2, y would also change. But like, this slope b is used to indicate how much changes y will have for a unit change of x. That's 1 unit change of x. Intercept a is used to show the value of y when x is 0. So that intercept a is just to show, oh, this is what y is when x is 0, when no effort is made, y will remain at this. So if an effort is made, it will change. That one effort was made, it will change. So b is going to indicate how much the y will change from what it was as when x was 0. Then the regression equation is used to make predictions. So that equation now is like, the equation is y is equal to 1.7x. So that equation now is used to make predictions. So you use that equation now. Using our example, you studied for 5 hours. Oh, you use the equation to make a prediction of, oh, since if I study for 5 hours, my test score can be this. If I study for 6 hours, my test score can be that. If I study for 2 hours, my test score will be this. So you use it to make predictions of what your test score would be like. So that line or that equation is used to make predictions. So for it to also another thing you need to do is to check the residual. So residual is the difference between the predicted y and the actual y for accuracy. So some questions, they can tell you, oh, find the prediction of this, and then they will tell you what your actual score was. For instance, your actual score was 70, and we predicted that if we study for 10 hours we'll get a score of 170, but then your actual score was 70. So the residual is 170 minus 70, which is 100. So we use it for, okay, we can use it for predicting grades from study time, or estimating height from age, or estimating weight from age. So it's usually used for mostly continuous time, like for continuous variables, that's like measurements time measurements, weight measurements, height, age, and so on. So if we've understood that, we'll be moving onto sampling. Is there any question? So far, is there any question? Is there any question, or should we move on? So introduction to sampling. So sampling is like a process of selecting a portion of sample from a larger group of population to estimate characteristics of the whole. It's just like an example. A very common example is when we get a bag of rice, or when we want to buy a bag of rice or a bag of beans. For example, we'll tell the market seller to just give you a cup so you can test and know how the grain of rice is. So you would see that you would measure the characteristics of the whole bag from the grain you are seeing that you've gotten from the bag. So we'll select a portion, that's a sample from a larger group, to estimate the characteristics of the whole group. So we have different types. We have two
Hello, good
types of.
evening.
Yes.
Excuse me, ma. Please remember
Yes.
to send a PDF of this class, please, so you can do revision
Okay, no problem.
with the groups. Yeah, thank you, ma.
No problem. So we have two types of population. We have finite population and infinite population. So finite population is something you can count. Students in your class, how many fingers you have, how many people are in a room. You can count that. Infinite population is like uncountable, or they are very large. Like you can't count sand, you can't count the grain of rice. So that's for, these are the types of population. So finite population versus infinite population. As I said, infinite population is countable. Infinite population, they are too large to count, and these have their own impact in sampling and calculation. So sampling from finite population, when you are trying to sample, you will get an exact calculation, an exact you know that this is 20 people in a class. You want to sample out 5 people, you just pick out 5 from the class. You know how many you've picked out, you know what is left in the class. So infinite, you cannot really know how many you picked. You just make assumptions and approximation, like you getting a cup of rice, you don't know how many pieces of rice you've picked or how many is left in the bag. So that is infinite and finite, like you comparing both of them. So we have different sampling techniques. We have simple random sampling, we have stratified sampling, systematic sampling, cluster sampling, and convenience sampling. So simple random sampling now, every member has an equal chance of being selected. This is mainly done in when there is finite population, when there is a small number of people and you can count how many they are. So you want to pick one person from a class. Everybody in that class has okay, in a class of 15, you want to pick 5 people. Everybody in that class has an opportunity to be picked. Nobody knows who is going to be picked. So it's just a random sampling. You can just randomly select 5 people from that class. So everybody has a chance of being selected. Stratified sampling is like when you want to pick out a particular group from a group of people. So let me say, in a population now, you want to pick out 4 girls and 4 boys. So like you have to like separate them into groups. So you know that, oh, you want to pick out 4 girls and 4 boys. So you separate them first of all into groups of girls and boys. So in the groups of girls and boys, you will now pick out the boys and the 4 girls and the 4 boys. So that is for stratified sampling. Systematic sampling, select every every K member. So like it's just like you selecting from a list of 100, you just randomly select the 10th person. When you remove the 10th person, the list will the number would the 10th person will be out of the list. You select the next 10th person. The other that person you selected will be out of the group. You select the next 10th person. So it's a group of selecting um samples, or selecting people from a group using nth term. So cluster sampling selects the entire group clusters like randomly. It's just like you selecting like using a bag of rice, just select entire groups like randomly in clusters, that's like in groups. In a particular group of places now, there is men, women, children. There are men, women, and children. You just select children. So that's like you just selected this group in cluster, like you just took them. And say you just decide to take only the men. So that's like selecting an entire group. So convenience sampling is just like based on selecting something based on ease of access. Maybe you just like decide to take this one. You're trying there are a group of books there. You just decide to pick this book because oh, this is the closest to you. So you just took that one. That's like based on ease of access. You just took that one because oh, that's the easiest for you to pick at that moment. So using an example, so a researcher wants to select 10 students from a class of 100. So let us see the different methods that can be used. Using sampling, simple random sampling. It will assign number 100, 1 to 100 and use random numbers to pick people. So there are 100 in the class. You just assign, oh, this is number 1 to 100. You can just decide to pick, oh, number 5, come out, number 6, come out, 7. So you just pick out 10 people from that group. So as I said, everybody has a chance of getting picked. So using systematic sampling. So as I said, you can choose every 10th student from the list. You can choose every third student from the list the same way as I said earlier. So using stratified sampling, so you can decide to divide the students by gender or department, then sample proportionally. So maybe when you so to make it fair, you divide the students into different departments. You have computer science, you have biological science, you have chemistry students. You just decide to pick one out of every department. So that's for stratified sampling. You divide them into group. So in case you're using gender or you're trying to like use a group, you can use stratified sampling. So depending on the question, they say, oh, select the students based on gender or based on this particular group. Or you would know that you are using stratified sampling because you divide them into stratas, like which is group. So another example, okay, I think this and that example using the same thing I said earlier. If you're trying to like pick them based on gender, you use stratified sampling. So for you to like know the sampling method that is based that is best for your question, you first of all find out the purpose of the study. If it's oh, you are trying to like pick for children, you would know that you are going to use this one. You are going to use cluster sampling. Then if it's based on size, you know if you are using size now, you cannot use random sampling method because you don't know how many they are. So you just you can decide to just use cluster sampling or stratified sampling. So you have to know the size, whether it's gender based, the purpose of your study, need for fairness or balance. If it's need for fairness or balance, you use stratified um sampling, which will help you to like pick equal girls and equal boys, equal people from each department. So you need to know like what's the reason of the sampling, or for you to know the sampling method you're going to use. So if we've understood to this point, let's just run everything down using an example. Do we understood have we understood to now? Or do we have any question? Do we have any question? Do we have any question? Okay. So like let's just run down everything we have done. So as I said, correlation measures strength and relationship. Person like examples of correlation is person linear, Spearman, it's just and regression. All these things are still measuring strength of relationship. So person is used for linear, then Spearman is used for ranks. Like when you're trying to like rank something, this is greater than this is first, second, third. Regression predicts one variable from another variable. Sampling is used to vary randomness or population size. So using a sample exam question, So given data x is 1, 2, 3, 4 and y is 2, 4, 6, 8, calculate the Pearson's correlation coefficient, find the regression line y on x, predict y when x is equal to 5. So the first thing you will do is write out your x and y values in a column. Then you find the square of x, 12, 1, 4, square of 2, 4, square of 3, 9, square of 4 is 16. Then you find the square of y, square of 2 is 4, square of 4 is 16, square of 6 is 36, square of 8 is 64. Then you find x and y. X and y, that's 1 times 2, 2, 2 times 4, 8, 3 times 6, 18, 4 times 8 is 32. So you add up your values. Adding up your values, you write it under. You can just decide to write it like this and remove this, then you write it over sigma 60. So your Pearson's correlation relationship coefficient is R, and the formula is n times sigma x y minus sigma x times sigma y over square root of n times sigma x square minus sigma x all
Excuse me,
square.
ma'am.
Yes.
I didn't understand the sign. You say square root. The first one, we should write it down and square the number. I didn't understand it.
So what did you say? I didn't understand your question.
You say there's somewhere you say that you should square the number.
I said here, is it in this equation you're talking of?
I can't see the
This
sign.
formula.
No,
You
on
say you can't
the
see
where
the
you write
square root.
244 okay,
See the
okay.
square root here.
The one up, what about the one up?
There's no square root. This is n times sigma xy minus sigma x times sigma y over square root of this. Do you
Okay, this
understand?
is the formula. Yeah, the
Yes,
formula.
there's a square root here. It's because of like on my phone screen, so it's written like it's a very small square root sign there. But this is the square root here. The square root is covering the denominator. Do you understand now?
Yes, ma'am.
So your Pearson's formula is R is equal to n times sigma xy minus sigma x times sigma y over all square root n times sigma x square minus sigma x all square times n times sigma y square minus sigma y all square. So this is your value. This is the values from calculating. So you first of all calculate the the numerator, or you can just do it straightforward. Anyhow you understand. But I just broke it down, so I will explain it. So you first of all do the numerator. So n times sigma xy. We found that our sigma xy is 60. So and our number of pairs is 4. So 4 times 60 minus sigma x is 10. Then sigma y is 20. Sigma x is adding all the values of x. Sigma y is adding all the values of y. So we'll solve them individually, then minus 6 times 40 is 240. 10 times 20 is 200. When you minus out, we have 40, and we have 40 for the numerator. So now we'll solve for the denominator. That's the down part of the fraction. That's square root. For if you don't understand, this square root is covering up everything here. So is n times sigma x square minus sigma x all square times n times sigma y square minus sigma y all square. So we have 4 times 30 minus 10 square. Remember, after adding is sigma x all square. So you first of all find sigma x before you square it. Don't make that mistake. The first one is sigma x square. So you first of all find out x squared, then you add all the x squared to get this first one. Then for the second one, you have sigma x, then you square it. So we have 4 times 30 minus 10 square times the same thing for y. Sigma y square is you find y square and add everything to get sigma y square. Then this one that the square is outside the bracket, sigma y all square, that's you add y, the value of y, then you square it. So you have 4 times 120 minus 20 square. So we have 120 minus 100. Remember, solve the brackets first using your board mass way of solving. Then 480 minus 400, that's 80. So we have 20 times 80, that's 1600. Then square root of 1600 is 40. So putting back into our formula, that's r over the numerator over denominator. So we have 40 over 40, which is 1. And when your r is 1, it means this is a perfect positive correlation. That's a perfect positive correlation. And the question also asks us to find the regression line of y on x. And the equation is y is equal to a plus b x. So the formula for finding b is n times sigma xy minus sigma x times sigma y over n times sigma x square minus sigma x all square. So using the earlier values, that's the one we have already calculated using this table, we'll plug it into the formula of b. So using our formula, we'll have 4 times 60 minus 10 times 20 over 4 times 30 minus 10 square. So we have our b as 2. So our b is equal to 2. So we'll find a using the same formula. When you find a using this regression formula, which is, sorry, let me write it out. I'm coming. Which is sigma, I think sigma y. Yes, let me write it out here. Where is the slide? So we have a is sigma y minus b. So I don't write in sigma over n. So you put it into your formula and then you get a, and a is b. So your regression line is going to be, your a is going to be 0. So your regression line is y is equal to 0 plus 2x. So they told you to predict y when x is 5. So you just put your x as 5. So we'll have y is equal to 2 times 5 is equal to 10. If they tell you to predict y when x is 20, we'll have y is equal to 2 times 20, which is 40. So they can also tell you find the residual value when the actual value of y is 10. So for instance, now you've already predicted that y is, when the actual value of y is 20, and you've already predicted that y is 10. So the residual value is 20 minus 10, and that is 20 minus 10, and that is 10. So your residual value is 10. So when you are trying to like know the differences between correlation, regression, and sampling, correlation is used to compare something. So like the same thing I said earlier, the same example, like does increased study time mean better grade? So like the more you study means like the more you're getting more knowledge. So that means more better grade. So like there's a relationship between these two things. Then regression is used to, like, let me say you're trying to like predict your monthly spending based from income, like This is your income. You're trying to see, oh, this is what I spend. These are just like real life illustrations of regression. Then something is how to survey product preferences. Like the example I gave, you buying rice, you can sample like different rice grains and see the differences between both of them, so like you choose the one which you prefer the most. Do we all understand? Because we've come to the end of our slides. Is there any question anywhere? Is there any question?
Okay. I have a question on number 21.
In slide 21?
Yes, ma'am. Okay,
Yes.
slide 21. Is that in question? Or
See the question here. This question is in slide 20.
I mean on slide 21, is the that thing up? Is it a question or answer?
Which thing up? Sorry. Is it the table?
No, yeah, it's the table. Is it from the question?
Yes, the question gave you values of x and y. So we use the values of x and y to form the table. Your first column is x. You write out the value in which the question gave you. You write it out in the column. Then y, you write it out. Then you find x squared by finding the square of this x column. That's 1 square will give you
Okay.
1. 2 square will give you 4. 3 square 9. 4 square 16. Then the next column is going to be y square. So you find y square by 2 times 2 square 4, 4 square 16, 6 square 36, 8 square 64. Then you find the value of x and y by multiplying x and y. So you find the value of xy by multiplying x and y. That's 1 times 2. This 1 times 2, 2. 2 times 4, 8. 3 times 6, 18. 4 times 8, 32. Then this sigma 10 is the sum of everything on this column will give you 10. If you add everything here, you have 10. If you add everything here, you have 20. If you add everything here, you have 30. If you add everything here, you have 120. If you add everything here, 60. Do you understand?
Yes, ma'am, I understand. Thank you, ma'am.
Welcome. Is there any other question? Is there any
No,
other
ma'am. No, ma'am.
question?
No, ma'am.
Okay, there are also two formulas. Sorry, there are also two formulas for finding A. You can find A as mean of y minus b times mean of x, or this is the second formula, or you use this. Where is it? Coming. Or you use this formula, sigma y minus b sigma ex, sigma x over n, or you have sigma y minus mean A is equal to mean of y minus b mean of x. It's the same thing. Both of them, they will give you the same answer. Mean of y means you add up all the values of y and divide it by the number. That's from this our question. We had 1, 2, 3, 4. So you add up everything and divide it by 4. So that will still give you the same answer by using this other formula. And write it out well here. B sigma ex over n. So it still give you the same answer whether you do this. Sorry, this is minus. So that's the same thing. Is there any question? If there's no
No, ma'am.
question, I think if there's no question, this is the end of our class for today.
Okay.
Thank you.